vaporization. Alright, Chris, what is heat of fusion?
Heat of fusion is heat per mass unit.
Good job. Now, if it's heat of fusion, are you going from solid to liquid or liquid to gas?
Liquid to gas. Solid to liquid.
Solid to liquid. Alright, we'll talk about that later. Okay, so, I'm sorry, Ethan, what is heat of vaporization?
Heat of vaporization is the amount of heat per unit mass required to vaporize a substance.
So if you're vaporizing it or evaporating it, that's another term for it. Are you going from a liquid to a solid, or are you going from a liquid to a gas?
Gas.
Liquid to a gas. So it's talking about, okay, basically how much heat it is to melt something, that's heat of fusion. How much heat is required to cause something to evaporate, that's heat of evaporation or heat of vaporization. Alright, I'll come back. Alright, so let's go over problem number 3 now. So sodium metal reacts violently with water to produce an aqueous sodium hydroxide and hydrogen gas. Calculate the enthalpy change for this reaction. Now, yes, you did have to figure out and balance this equation first off. Your books kind of doesn't do that for you a lot anymore. Sometimes it still does. But it's because it wants you to practice still balancing, because you need to keep that skill. You don't need to forget it. Alright, thank you. Alright, so number 1, or who wants to give the balanced equation? I think we got it. Alright, Chris.
2Na plus 3H2O goes to 2NaOH3 and then plus H.
Did you say OH3?
Yeah.
Why is it OH3?
Because it's sodium carbonate.
Alright, so sodium wants to give how many electrons?
2.
1. Remember, it's on group 1. So it wants to give up 1. Hydroxide takes how many? 1. So this is actually already, like, the electrons are balanced as is. So we'll fix it in just a second though. Alright, and then
Plus H.
and H2 by itself?
No, it's not. It's H2.
There you go. Alright, so now let's fix it really quick. So what do you need to fix for it? You're close.
So on the right side you have 4 H's, and on the left side you have 6. So just put a 6 there. No, put a 4. And then you put a 2 in front of the H2. No, just put a 3 in front of the H2 and it's balanced.
In front of the H2 for this one?
Yeah, it's balanced.
How many O's do you have on the reactant side?
Put a 4 in front of the Na. Oh.
Okay, let's start over. I think you're getting stuck and trying to do it quick. Alright, so this is the correct molecular side of it. Okay, so just balance it. Which one do you want to do? N, O, or H first? You probably don't want to do H's because you have 2 here and then there's 3 over on this side. You should probably
I'm gonna go with H's first.
Okay.
Let me go 2 H2O, put a 2 there. And put a 2 in front of the NaOH. And put a 2 in front of the Na.
Done?
Yes.
Now it is correct. Alright, so that's what you need to do for it. So it's 2 Na plus 2 water molecules and then 2 sodium hydroxide and then 2 molecules of hydrogen. Good job, yeah. That's the reason why we still practice these. Alright, so this is the balance portion of it, but that's not done because what it's asking you is it's asking you to calculate the enthalpy change or that change of entropy, or not entropy, enthalpy on the inside of it. Alright, so for the equation, if I'm finding delta H, that's a decent delta, how do I find that one? What's my equation? I'm going to slide, I don't think Debbie can see anymore.
Isn't it plus Q minus Q?
Nope, it's
That's delta E.
Delta H equals delta H degree P, and then the P with the parentheses.
Oh, you're finding out enthalpy just by itself. If you're talking about what enthalpy changes with reactions, what's the equation for it?
No, you help that's Quentin.
Yeah, it is. You're on the right page.
Delta H
Okay.
on the right side. Plus the 2. Mine is delta H, yeah.
Yeah. Alright, and then what did you say goes down here? I think I missed it.
Nothing.
That's what I had.
Product with minus
Oh.
B.
That's what I had.
Oh, you're talking. Oh, I thought you were talking about where it's
You
H
said
equals E plus P over B. That's what I thought you meant.
No.
So I'm sorry. Okay.
The P in parentheses at the bottom.
Alright,
That's
so
what
tiny and trying to make sure Jamie can see everything, so I'm gonna keep glancing at the screen, making sure I'm not moving off the side. Alright, so I have to figure out, okay, how much heat is in the reactant side, or enthalpy change is on the reactant side, and then I have, not reactant side, product side, and then I figure out how much enthalpy change is on the reactant side, and then I subtract the reactants from the product. Okay, so if I'm looking at this side first, what table can I use to figure out what is the standard heat of formation or standard enthalpy of formation to figure out?
Table was like 6.2, wasn't it?
Yep, good job, table. It's the table on page 84, so standard enthalpies of formation. So standard enthalpy of formation. Alright, so what is sodium hydroxide in the aqueous forms? You have to find that one specifically. Did you find that one, Ethan? Because you got kind of close.
In the liquid form,
Is it like
Aqueous form, AQ.
469?
What was it?
Is it like 469.60?
Good job, that one is it. So, that one is negative 469.60 kilojoules. So, that's the sodium one. Alright, and then, yep, that's sodium. So keep in mind, if there's 2 moles of sodium, what do I have to do? Yep, we'll solve it in just a second. Alright, hydrogen, free and uncombined at its standard state. What does it always get if it's free and uncombined at a standard state? This is our reference point. 0. So, it's 0, but you can just know, okay, I don't care about that right now. Alright, so come over here to sodium. Sodium, free and uncombined at its standard state. 0. So, even though there's 2 of them, don't care. So, you can basically exit them out. Now, water, this is water, specifically liquid water. So, Ethan, did you find liquid water previously?
Is it 74.85? For
285.8.
water?
Yeah, for liquid water specifically. You have to have H2OL.
Oh, no,
285.
285.8.
That's it. So negative
I had that.
285.8 kilojoules. Alright, so how many molecules of water do I have? 2. Alright, so I have to say, okay, it is the reactants are subtracted from the products. So it's 2 times this, so this is the product first off. So 2 times negative 469.6 is what? Quentin?
939.2.
Say it again.
939.2.
Did you just do that in your head? Good. So that's the products. Alright, and then the reactants are what? 285.8.
500.
Wait, see what we do.
386.
Say it again.
386.
386? I just can't hear you through the master bell, I'm sorry.
386.6.
Alright, Chris.
I pressed the
Oh,
button.
370.6.
Okay, it's 2 times
Or
285.
Negative 571.6.
Oh.
Yeah,
It's on the
negative
bottom.
571 point. Oh, you said 16.8.
0.6.
No, it is 0.6. I'm sorry, I looked at the wrong number. 0.6. Alright. So, this is the reactant. That's super messy. I gotta fix that. It's super bothering me.
That's almost like your delta signs.
I'm trying.
Oh,
Alright,
I like it.
so if you have a minus subtracting a minus, what happens?
Flip this
Positive.
Yeah, it'll be plus the positive. So the answer for this comes out to what? If you have a
side.
calculator,
Negative
plus
367.6.
7.6 kilojoules. Alright, so looking at sig figs. How many sig figs?
4.
How many sig figs?
4.
5.
Four.
Technically.
4.
Look at that
5.
paper.
Alright, so the last step was addition or subtract. Was the last step was addition or subtraction? So you go off number, or do you go by place?
Place.
Place. This one ends in the ones, this one ends in the ones. So where should your answer in?
Right where it is.
Yay! So everything's already done.
Yeah,
Alright,
you need
so
some- you need
It's on
some-
my eye.
alright,
That's
wait.
all I
So
do.
this is negative for changing of enthalpy. Does that mean this is exothermic or endothermic?
Indifferent. Except.
Exothermic, because it's losing heat. So that's the idea, that it's negative, that it's getting rid of it, it's lost. It's like your bank statement, it's negative. Alright, anyone have any
Good
questions
point.
about how to solve that? Alright, let's review really quick, so you can get a little
There
bit
better
of
be a
review.
red dice in there.
The junior higher school, I'm sorry.
You should have those red eyes, I will get it.
I'm sorry, the junior hires came to pick them up. They did all the pretty colors first thing in the morning. I'll try to clean them before history class later.
What school calling us?
Alright, so gonna do it, but basically, speed dice. So basically, I'm gonna ask a question, you get it right, you roll your dice. If it rolls on the floor, it's a 0. So if you don't get it right, it's
We played this mileage, didn't we? No, we had too many kids,
we had to use we used the giant
used the
dice.
big dice.
Yeah, I can't use
Big-
that one this year.
We used the chase dice.
I just can't use that one because of Corona. So I think I'm gonna have to get some more dice. I had to find them from Target.
You know, Corona's actually been around for 2 years. We just discovered it in December.
Alright, so thinking about it, what is the symbol that means change? We'll just start with Chris and go backwards.
Isn't it a letter?
I guess.
Is it an E?
Technically.
Is it an E?
That means change.
C?
Are you going with yes C or like the letter C?
Yes, C.
No. Okay.
Delta.
Delta. So I guess technically it's a Greek letter, but it's not a
Wrong.
hard letter. So delta. Alright, what is the symbol that's used for heat?
Q.
Q. You gotta know your letters or your symbols.
T.
Alright. There. Which one stands for work?
T.
You go T?
No, we'll start with.
What letter
W.
stands for yes.
1, 2,
Alright, what
Oh,
letter
maybe a
stands
symbol.
for internal energy?
J.
You sure?
Yes.
Nope.
No.
Internal energy.
Let's start with.
What letter?
Internal energy?
Internal energy. What?
E.
Is it, I'm sorry. E?
Yep.
Yes. Alright, enthalpy.
Isn't it delta?
You're thinking change of something. So what letter just means enthalpy?
It's a letter.
It's a letter.
Q. W. No, I already. Alright.
I was watching Wheel of Fortune and I got guess
H.
what letter you already said.
You're going shit? H?
Yes.
Okay, yes.
126 now.
Alright, what is the SI unit of energy?
Joule.
That's joule. That's where and that's where the
Yeah,
third
that's
J is
what
coming
we
from.
don't
Yeah.
like drooling.
What a guess!
Alright, give an example of an exothermic reaction or an exothermic process. Heat created.
Exothermic, so that means ice melting.
Alright, if ice is melting, is it gaining or losing energy?
Losing.
It's losing energy if the ice cube is melting?
Forget I said that.
Okay.
You wanna say
Exothermic means it's losing energy, so,
Yeah.
um,
It's producing a lot of heat. So that'd be an example of something that produces a lot of
I'm
heat.
next, right?
Yes.
the sun and its heat.
That is not count. That is not count.
The heat comes
If I
off
get
the
closer,
sun.
if I get
It's
closer, if I
li-
get closer, if I get closer.
No.
Technically, it has to do with fusion
Me.
and an exothermic reaction.
Me, I am
I'll take it.
exothermic.
Roll the dice. But yeah, basically anything like fireworks, burning something.
Running.
What?
Running.
Okay, with your body generating heat. That would be an exothermic process. Okay, I'll take it. Alright, endothermic process.
Ice melting.
Yes. Okay, because an ice cube has to absorb heat for it to go from a solid to a liquid. Alright.
Paper.
Alright. What stands for specific heat? What letter? I knew I had way more letters than this.
Come on, Chris,
Yes.
you got this.
S?
Yeah.
Nope.
Lowercase c.
C. Little c specifically. Alright.
Third five.
What is the equation to find specific heat?
Delta H.
And just like that?
Delta HF. I don't know.
Alright, Quentin.
Oh.
Alright, Ethan.
C equals Q over H.
Oh.
H delta T. That?
Yes.
Hot.
No. C equals Q over. You can take that, right?
No. Alright,
Ah,
we're close though. So it's M delta T, so it's mass. So just be careful for it. Alright. Let's see. I think that's as far as we've gotten really for yesterday. So what is it? Oh, I didn't go through one more time for people. Alright, what do you call the device that's used for measuring heat flow?
So it's the C.
It does.
Is it quadrometer?
That's a cube.
I don't think I can take that. You have the right idea, you have the
Can't
C and you have meter.
Is it can
She said she can't take it, so it's next
What?
person's turn.
Kilometer?
Okay.
Cat and a half.
Like, kilometer or kilometer?
Kilometer, you want with kilometer?
Yes.
No.
That's a mile.
Calorimeter.
Okay, alright, okay.
Calor,
Calorimeter is how you're supposed to say
C-A-L-O-R-I-M-E-T.
it. It looks like calorie emitter, but it's calorimeter.
So I can have it?
Cauliflower.
Don't like cauliflower. Alright, I can go one more time, I think through everybody now then. Alright, what is, what do we call the total amount of heat liberated or absorbed between the start of a reaction and the end?
Just sort of.
H.
Say it again.
What do you call the total amount of heat liberated or absorbed between the start of a reaction and the end? Where all the types of the terms of the original
Heat, is
reaction.
it heat total?
Heat of,
Heat of fusion.
we're talking about a reaction.
Heat of reaction.
There you go, roll. Roll it.
So it's in there?
Gave it to you. Alright,
No, you did not.
what
I'm so
is the assigned enthalpy of a free and uncombined element at its standard state?
Let's start with.
Oh, I erased it.
What was it again?
So, free and uncombined, what do we call, what was given for our reference point for the enthalpy?
Let's start with.
0.
Okay.
Starts with 0?
No, it's a reference point of 0.
She
Alright,
started. G.
what symbol do we use to denote standard enthalpy of formation?
What?
Alright, so what symbol is a collection of them? So, standard enthalpy of formation.
Delta H.
It is delta H, and then what else does it have? If it's a formation. Little F, and what goes up here?
Degree.
There you go, that's it. Alright, roll.
Core.
Alright, we'll go ahead and we'll stop there. Who has, y'all made it through a couple times, who has 15 or more? Alright, 20 or more? 25 or more?
How do you have
Alright.
I got 8, 4, 7, 7.
No.
I will clean them later.
That's big luck. That's
Alright,
big.
go ahead and turn in your textbook now to page number 85. We gotta finish talking about mass heat calculation. So we're still working with the standard enthalpy of formation, talking about the reactions with the substance. So we've gone through and we've practiced with your homework. Okay, if I'm given so many moles of this substance, I plug it in and I figure out, okay, how much heat is generated? Is it endothermic or exothermic? But most of the time, whenever you're given a substance, you're not giving it in moles, you're giving it in grams. So, thinking back, if I want to go from grams to moles, what do I have to use?
Avogadro number.
Or, more conveniently, what do I use?
6.03 times 10 to the 23rd.
More conveniently, if I'm going from grams to moles.
Mole mass.
Yep, so that's what we're going to use for it. So I'm going to talk about with mass heat calculations. Doesn't really walk you through like step by step. So if you want to mark it as I go through it and then mark it in the practice problem, that's probably the easiest way to do it because it doesn't give you like a list. Alright, so it says to find the standard enthalpy of formation for like 500 grams of ethanol, you would first figure out what the standard,
They showed the video.
That's a
Yeah,
ton
keep
of
it going.
that's a ton of ethanol.
yeah, that is a lot. But it's just saying, like, remember, ethanol is used with combustion, with rockets. That's where you want to see, okay, if you have 500 grams of the substance, how much would the reaction occur for it? So, to find it, you want to figure out how you want to calculate the number of moles in 500 grams of ethanol, and then and then multiply the value of the standard heat of formation that you got from your equation, and then multiply it by how many moles you actually have. Like with the equation on page 84, your book's using that one as kind of like a part 2. So looking at the balanced equation on page 84, how many moles of ethanol do you have in that reaction?
46.0 something.
Not sure where you get that number. Okay, looking at the equation on page 84 with the example 6.4, how many moles of ethanol do I have? Or molecules of ethanol do I have? Yep, just one. Now, okay, so your book is using this as kind of like a part 2. What was the answer to that whole first example problem on page 6.4? We worked this out yesterday in class. You can also look in the book. What was the answer to it?
Negative 1366.7.
Yeah, so that is negative 1,366.7 kilojoules. So that is the delta H for this reaction. They say, okay, that is for 1 mole. We don't know if we have 1 mole. If I have 500 grams of ethanol, do I know if I have 1 mole or not? Or how do I figure it out?
You have to figure it out more than.
Yeah, so you have to figure out what's going on. So the parts of ethanol are C2H5OH. Alright, so what is the molar mass of ethanol? How do you figure this out?
Molar mass of ethanol is 46.0.
Cheater. pumpkin eater. For
Yeah.
the sake of speed,
That's
how he is.
so we will move on from it, but
That's
yes.
just how he is.
Alright, so the molar mass is 46.068. Alright, so now that I know molar mass, what do? What do I do with this number?
Divide it into 500.
Yep. And that'll give you how many moles?
10, 20,
Where are we at?
25.
We're on page 85, and Chris is reading the book. But it's okay, we're gonna practice in a second, so if you're trying to read through the book quickly, you're gonna get in trouble in a second. Alright,
Y'all
so,
are just mad because I got a big brain.
it's okay. Alright, Chris, how many moles do you get?
10.85.
Yeah, technically, February calculator is 10.853, but yeah, your book is rounding to 4 sig figs. Okay, so if this is how many moles I actually get from ethanol, and this is from 1 mole, what do I do to figure out how much total moles, how much total energy is generated?
Multiply by negative 1377. What if I go
So you would multiply the actual mole amount you got, even where it correctly or not at all. So you multiply this amount times the amount given from 1 mole, which is what, Quentin? Some of you participate.
Well, I can't answer it.
No, you've been answering a bunch of them. Find it.
Look at the book.
Negative 14,830.
Good job. So it comes out to negative 4,828, but your book's rounding to 4 sig figs because that's what they started. Well, 3 sig. No, they started off with 4 sig figs. So that's the reason why they're starting off with that. So rounding it to 4 sig figs, it becomes 14,830. No decimal point. Kilojoules. So that's where the answer to that one comes from. Okay. Now you're gonna practice with my problems so that you can't cheat off them anymore. Okay. So this first one has to do with, again, just practicing with, I moved it around. It has to do with practicing with figuring out what the heat of formation first off. So just these 2 problems, I'm gonna change the background really quick because I think, did it show up in the video better if it being black with the other words? Does that
Yes,
actually help?
it did.
Okay.
What's Athene?
Ethylene?
There's no L.
Oh, ethene, sorry.
Oh.
I think it's supposed to be ethene. Pretty sure it's ethene. It looks like ethene. Let me change the background then really quick. So Jamie can see it. If you can read this, because y'all have eyeballs, so y'all can actually read this one. Y'all go ahead and read it. So, the combustion of ethene with oxygen occurs in the following reaction. What is the enthalpy change for this reaction? So, what table did you use to figure this out?
6.2 table.
Yep, on page 4. So go ahead and start solving on your own. I'll help you in a second if you get 100% stuff and you have no idea what you're doing anymore. I will help you.
What-
So we balanced.
Yes, I gave you already balanced ones, so I felt like that would be nicer.
Nicer?
Nicer. More nice.
Thank you.
I
Change.
think we need to
I need a pen.
That should be easier for me.
I need a pen.
So 302, that's just 0, right?
Why?
Is that balanced?
My signs went away. I can change that color.
It's I.
Okay, that's just there. I'm sorry, Jamie, I know you can't see that.
Is that balanced?
Yes, it is balanced already.
So 302, I don't see that on this table.
Alright, is O2 free and uncombined?
Yes,
Yeah, so what's it got?
0.
0. So yeah, answer your question back abstracted, I'm sorry.
Is that a G or an L for 2H2O?
Oh, I'm sorry, that's not gonna show up. Okay, yeah, this is a G, this one is a G, this one is a G, this is liquid form. I'm sorry, Jimmy, I don't think I can make it any bigger and it show up right on the screen. It's gonna get too large. Yeah, I don't know if I'll get, I'll try to make it zoom in a little bit. Yeah, all of them are gases except for the water. Tell me if it comes up the edge of the screen.
Better.
Okay, okay. I think that might be as close, yeah, cause it's gonna fall off the screen if I get too large, if I get larger than this. Okay. Oh, I should change my slide. Alright, so it's ethene with gaseous oxygen, yields, my arrow went away when I changed the color, and then gaseous carbon dioxide and liquid water. Alright, so let's go through and at least see where you're at for it. Alright, so has anyone found the heat of formation for ethene first off?
$52.30.
Alright, so I'm just gonna write them on the side so we won't forget about them because we're gonna need them in a minute. So,
I have all of them already.
oh, we gotta
I
share,
have
but
to
thank
all.
you. Alright, so H2. Alright, Ethan, what do you got for this first one?
52.30.
There you go. Alright, remember it's kilojoules. Is it positive or negative? I missed that part.
It's positive.
Positive. Alright, what have you got for carbon dioxide, Chris?
Negative 787.
Carbon dioxide and gas?
Yeah, cause you have times it by 2 because it's 0.
Oh, okay, don't do that part yet. So just what's just one for just one
Negative
individual one?
393.
There you go. So negative 393.5. You're right, you will double them in just a second. Just hang on. Alright.
There.
And then water. What do you got for water?
Negative 285.8.
There you go. Alright, so I have to figure out what's the total amount for the product side. So if this is my products, what do I do for that side? Chris,
You have to multiply them by 2.
get up.
So you get negative 787 and negative 571.6.
Alright, and so what's the total for the product side? I'm just gonna write P for product, just write it off the side.
Negative 215.4.
Alright, it's 2 times the negative 293.5, 2 times the negative 285.8, and then it's a negative plus the negative.
Yeah, I know already. I did that. You got negative 215.4.
Double check it one more time.
Okay, because you got negative 787.
Okay, where are you getting,
Because you're multiplying the 393.5 times 2.
let me type it in my head, so I can see where you're getting stuff, because I can break it down that far.
What is the product side?
This is we're doing the product side first, so it's the water and the
So
carbon
it's
dioxide.
52.30, right?
Alright.
No, it's not.
It's 2 times this one,
Okay,
because
so
there's
we're
2
done products.
carbon dioxide and there's 2 waters.
That's
So you
reactant
get
side.
negative 787 for the 393.5.
Let me type it in.
Did you say we were doing product side then?
Yes.
Then isn't it just
That's the reactant side that you're thinking of.
No.
This one is on the reactant side. These two, so look at this equation. So carbon dioxide.
C2H4 is on the product side.
No, it's not.
Hang on. What do you? I can't focus on both at once. Say it again.
C2H4 is on the product side.
C2H4. Oh, this is reactant side. Reactant and then product.
I thought reactants were on the right side, or the left side.
Yeah. So C2H4 is on the reactant
I'm
side.
confused, I'm so confused.
It's okay. I think you're just getting a mix of it. So products are on the right. Reactants are on the left. We're doing products first.
Okay, yeah, now I'm
Alright, so it's 2 times this amount, and they're right there on the side.
Yeah,
2
okay.
times this one, and then together. Alright, let me double check because I can figure out what you're doing for it. So 2 times negative 3.
Wait, isn't it negative 1,358.6?
Say one more time? Yeah, that's it. Did you forget to change your signs? That's what it sounded like.
I did negative 787, and I changed the sign for that.
That's what you did. I was like, okay, you're doing something. I just couldn't figure out what you did. But yeah, so just keep your negative sign for it. So the product is, what you say, negative 1,300?
I already
58.6.
Point
That's
six.
what it should be. Alright, so this is the product side. Alright, the reactant side. So ethene is what?
52.30.
Alright, and how many ethenes do I have? 1. Alright, oxygen. Do we care about oxygen? No, because oxygen is free and it's 0. Alright, so what's the enthalpy for the reactants then?
52.30.
Yeah.
And then you add them?
Alright, so remember, it's the reactants are subtracted from the products. So,
Can I guess it?
you can try to guess it.
1,300.
Alright, well keep in mind,
6.3.
it's a negative minus a positive. So if it's a negative minus a positive, what happens?
It's a negative, right?
Yeah, it gets changed into a negative because the sign is flipped.
Negative 1,350. So you're adding now, right?
Yeah, because originally it's a negative, so minus a positive, but remember with the sign flips, it flips with whenever you're subtracting from
So
a
I already got the answer.
1,300.
Let's try one more time.
1,410.9.
Say it one more time.
1,410.9.
Yep. Alright, what's your units? This is kilojoules? Alright, is that your answer, Chris? Awesome. Alright, anyone have any questions about how to solve this one? So this is just practice.
I can do all that.
Alright, let's say, for of 1 mole of ethene, let's say I have 50 grams, I think I'm writing too far over here now, I'm sorry. Alright, 50 grams, if I have 50 grams of ethene, how do I figure out how many moles of ethene I got?
You take the 50, and then if you're doing it for what now?
And you
If
add
I'm
it.
trying to find how many moles, because this is how much heat is generated from 1 mole of ethene.
Why are you erasing all that?
Let's tell you right now. Alright,
So divide the negative 1,000 or 410.9 into the 50.
No, you add it to the 50.
Nope. So this is for 1 mole. How do I go from grams to moles?
You multiply.
Molar mass. So if I have 50 grams of ethene, how many moles is that? Alright, C2H4. Alright, how do I figure out molar mass of ethene? Can't cheat this time, it's not good.
But
Well, I mean, ultimately you will, but how do I just find molar mass? How do I just find it? Periodic table. So, go ahead and calculate that out. Figure out molar mass of ethene. So C2H4. Where's your calculator, Quentin? Alright, if it's not here tomorrow, I'm gonna have to start giving demerits for it. You need it. This is 1 more day of grace.
Yeah, boy.
Alright, C2H4. I'm gonna go ahead and move the energy so that
carbon
it
is
will be away.
12.01, right?
28.052.
Is everybody pick up? So 28.052. Alright, so if I have 50 grams, then it takes 28.052 grams to get 1 mole. Right. So how many will I have?
1.78.
2, and then I got tired of writing that one. Alright, so this is how many moles I have. If this is how much heat is generated by 1 mole, what do I do to figure out how much heat is generated altogether? Wait, Quentin. Multiply! So multiply these two numbers together and I'll give you your final answer. Alright, Chris, we'll let you solve it.
Negative 2,511.402.
Okay. So,
That's too many sig figs, right?
So how many sig figs should I have for this one?
So the last
Alright, I
thing you
started
did-
with
So the last
3
thing you
though.
did was multiply, so you go by how many sig figs you have, so 3. So it'd be 251.
Like that?
Yeah.
Point.
With this
That's
now?
4 sig figs.
Does it?
Yeah.
Why?
Oh, the 0 doesn't
There
count.
you go. And so that's what comes in this. Okay, anyone have any questions about how to solve that?
Never.
Alright, even if you got a slightly different answer because of rounding, that's one reason why we have sig figs, because it all comes out to the same answer for it. Alright, does anyone have any questions about how to solve this? Alright, problem 10, go! Alright, so, there is
What?
no, your table does not give you what the standard enthalpy formation is for sucrose, so that's what this number is. I went ahead and told you what that one is because I looked this one up, because your table does not tell you. So, Kish, you can't read it, Jamie, I'm sorry. So, negative 2,221.0.
So that's balanced?
Yes, this one I already gave you balanced.
What if I don't know how to do it?
What if you don't, what if you don't, it's gonna call you a lot then. Did you practice?
Okay, I'm good.
You should hopefully already have what carbon dioxide in gas form is, what water in gas form is.
Yeah, but yeah, you do, but then you have to multiply it. It's not water and gas form, it's water and liquid.
Well, yeah, you're right. It's water in liquid form and it's carbon dioxide in gas form. You should already have those values written down from the first problem though.
Yeah, but you have to multiply all of them.
That is true, you're right. You do have to multiply those. thing done?
close.
Okay.
I got the cookie thing done, I already got like.
Okay, that looks like that's for, products,
Yeah.
that is right for products.
And then this is the left side, here's the left side.
Yep, so what do you do now?
Now you, divide.
Not divide, cause remember, it's
Which one?
reactant subtracted from product.
Subtract,
Mm-hmm. Which one is your product?
left side, no, right side.
Right, so this is your product, this is your reactant. So this is this number subtracted from that number. And give your final answer.
I heard that.
Well, I mean, that's still just like the sticks, doesn't help you with numbers.
I got one there.
5, 6.
I'm missing your sign, but that is, well, yeah, that is the correct answer for it, so just write it down. And then just sit back for a second, 'cause I gotta help other people. If you wanna go ahead, Chris, and you want to try to solve it based off the idea of if you have 250.0 grams of sucrose and solve it that way, but I gotta help them. Alright, Ethan, what'd you get for the total heat, for the total, the total enthalpy of the products?
That's on the left side, right? The right side.
Right side is products.
7,863.4.
Alright, you got slightly off, but that's okay for it. So is it positive or negative?
Negative.
Negative. Alright, Quentin, what'd you get for reactants?
Negative 2,221.
Good job. So, because again, this oxygen doesn't count because it's green uncombined, so this is we don't care about that one anymore. So, negative 2,221 point, was it 12.0? Yeah, 12.0 kilojoules. Alright, so now what do I do? Divide? Add? Subtract. But you're alright that if you subtract, it does become a
You'll get there
positive.
eventually.
Alright, so what's the answer then? Do you still solve this in your head, Clinton?
Mm-hmm.
Okay, cool.
Negative 5,600. Isn't it supposed to be 21.0? On the reactant.
Oh, thank you. Oh, I skipped something.
400, or not 400, 42.4.
Yes.
Very close.
That's it.
So, 2,000, so, it's 7,800, I'm sorry, I copied it down wrong. I apologize, I'm sorry. I'm so sorry. Okay,
44.
good job, 0.8.
44.
Alright, so negative sign, so exothermic or endothermic, Ethan,
Endothermic.
negative?
I said exothermic.
I'm sorry, I thought
No,
you
it's
said,
fine.
I'm gonna say, I'm not sure I heard endothermic. Like, okay, maybe
I'm
it's
just
the
kidding.
math,
I did
maybe
that to my
it's
mom.
me.
I did that to my mom once, she said.
Okay, but yeah, okay, so this is the heat generated from 1 mole of sucrose, but now it's asking us, well, I'm telling you now, let's say we have 250 grams of sucrose. Okay, did you already figure out how many moles you get from this? Okay, we'll just let Chris tell us.
0.04543.
0.07.
4. 0.04. 453.
Alright, that's not what I got. Now, what did you get for the molar mass of sucrose?
550.296.
That's not what, how many carbons do you have?
Oh, I did plus the 12.
Oh, okay, well, I'll just go ahead, that for this one, for sake of time, so we can just go ahead and solve it, that the number of moles from 250 of these is 0.7304 moles. Alright, so if I get that many moles, did James still see this? Barely. So if I get that many moles, what do I do, Quentin? Multiply, you multiply these two numbers together, and then what do you get? Go.
6,785,325 billion. Ow.
You have a calculator.
I'm gonna say, you have a calculator.
Quinn, you can't do it.
Yeah, because I don't have a calculator.
You have a calculator in your brain. You can't.
Negative 4,122.96192.
Ah, 0.96, okay, and then we'll start from there. Alright, so if I started it with 4 sig figs, how many should my answer have?
4.
Alright, so what does it become? We'll let Ethan run, thank you for your man.
The what?
Alright, so what does this become in 4 sig figs?
Oh, yeah. Negative 4,022. No, 41,220. Right?
That?
No. 41,220.
41,200. What was that last bit?
41,220.
Like that?
Yes.
What are you doing? Okay, so my original number.
41,222.
What it is?
4,000.
0.9 something. Okay. 4
4,000.
sig figs. 4. Only need 4. Okay, I have 5 right now.
4,142.
There's 0.9.
Get rid of it. Okay. No, 4,123.
There you go. That's all I needed. Alright, and then this is kilojoules. What does this have to be?
Kilojoules.
Kilojoules. That's all I
Quinn
needed.
can't even say anything because at least he can remember to bring his calculator.
I mean,
I was
wait,
thinking
did
of
you
the
do it though?
Alright, anyone have a question about how to solve these type of problems? So it's one of those. Now again, for quizzes and tests, you're gonna have the chart, but I will tell you like this. Okay, what the standard heat formation is. Does anyone have any questions about how to solve something like this?
Can we not do this again?
I mean, not today, but
Yeah.
quizzes and tests coming. As a side note, your test is Tuesday.
What?
So make sure
Test?
that's what- yeah.
Like a legit test.
Yeah, like the next one is
You
Tuesday.
just had a exam
This
last week.
is-
Y'all have a good day.
Yeah. So make sure you're still focusing on
Why?
this. Alright, because it's just how it is.
How long after that do we have to learn the test?
About 2 to 3 weeks? It's about every 2 to 3 weeks, this is give or take. This is
Do we
week
have
2
jump off the
since
plane?
the quarter exam, because you had all of last week. This is week 2,
We
week
just
3 is
took
next
that.
week.
Quinn did
We
too.
took our exam last week, so technically.
No, it was week before.
Really?
We've had 3 weeks of
Quinn took
online
his last
school.
week.
Yeah.
That's
Alright, well let's go ahead and let's get into it. So heat changes and changes of state over on
I'm not
page
ready.
86. Alright, this one sounds super complicated, but it's actually not that bad for it. Now, for this one, we're getting into changes of state. Now, if you're going from state changes, what does that mean, Chris? State changes.
I have no idea.
Okay. Ethan, what state changes?
When you change states.
What's his start with?
Alright, so.
Is it gonna go from like liquid to gas?
Thank you. Yeah, so liquid to gas or gas to
I'm
solid. So
smart.
it's okay. It's been a while since we've used those terms. Alright, so for this one, we're talking about going from one state of matter into another state of matter. Alright, so if I have a cup of ice, alright, and I set up my cup of ice on the table, what's gonna happen to the ice cubes on the inside of it? They're gonna melt. Why? So if I have my water and my ice cubes, alright, what happens from, now let's say that the ice cubes are the system. Is the ice cubes gaining energy or losing energy?
Losing. Gaining.
Gaining, because they're gaining energy because the ice cubes are having to break apart their bonds to go from a solid to a liquid. Remember, solid has the least kinetic energy and gas has the most energy. Alright, you look confused. What's wrong?
I'm not confused.
What's wrong?
I'm looking at that drawing and it's confusing.
I'm
me.
trying, okay? I'm not an artist. So, now, my ice cubes are gaining energy. Now, what's going to happen to the water around it as the ice cubes are sucking in energy?
It's gonna gain energy.
The water's going to gain energy?
It's gonna lose energy.
It's going to lose energy. So that's how come if you have ice in a glass, your glass temperature goes colder because it's losing energy to melt your ice cubes. So, that's what it's talking about when we're just talking about state changes with something gaining or losing energy. We use water because water is a really common example. Alright, so the first one is heat of fusion. Alright, if I'm going from solid to a liquid, do I have to gain or lose energy? Gain. So will it be a positive sign from the standpoint of this object? Will it be a positive sign or a negative sign? Positive. So if you want to look at your little drawing where it says heat of fusion, and it tells you delta H fusion, because that's the symbol we use for it. So delta H fusion, that one, if you're going from a solid to a liquid, it's always gaining energy. Let's say though, I want to take it backwards, and I want to suck out energy to make it go from a liquid to a solid. Will I have to put in energy or take it out? If I want to. Take it out. So will it be gaining or losing energy? Losing energy. So you will notice now this picture is from a physical science last year because your book decided to not give it to you this year, but I like it. So, your book points out that if you're going to take 1 gram of ice at 0 degrees Celsius and I want to melt it, I have to put in 334 joules for it to melt. So on this side, if I'm adding it into the water, would it be positive or negative?
Negative.
Positive. So let's say that I want to go the other direction. I need to take out 334 joules. It'll be negative. So you'll notice the amount is the exact same, but it's just because it's going from, okay, one state of matter. If I need it to go from one state into the next, you either have to put in energy or take it out. So that positive or negative side is the only difference between heat of fusion and heat of crystallization. Your book gives you that at the chart on the bottom page 86. It's the exact same amount for a substance. It just depends. Are you putting it in or are you taking it out? For convenience sake, most scientists would just refer to this as just heat of fusion, and they know, okay, if it's a positive, I'm putting heat in. If I'm taking heat out, it's negative. Technically, it's heat of crystallization, but your book just uses heat of fusion, and a lot of scientists just use heat of fusion as like a shortcut term.
The fact that it was a 50-50 and we got 1 out of 4 is sad.
What do you mean?
Saying positive or negative.
Right? It's been a while. It's been a long time. But yeah, my time just about up. So we're gonna stop there. We'll talk more about this tomorrow. We'll talk about the math in this tomorrow. It looks super scary, but it's not that bad. So read pages 86 through, I might get to talk about entropy tomorrow. So 86 through 88, you should have read it, at least part of it already. Alright, answer the concept reviews on page 88. Concept reviews 2 and 3. 2 and 3. Well, don't worry about the application yet. I'll help you out that one. You can do it now. On page 85, do problem number 4. So, you're going to do concept review on page 88, 2 and 3. Concept review on page 88, 2 and 3. On page 85, problem number 4. If you get stuck in that one, I highly recommend you just see me in study hall to help, so I can help you out for it. Because that's the one with the standard heat of formation.
Unless you're Jamie.
Yeah, Jamie just got a copy.
Standard heat of formation. Is that what we're doing today?
Yep, so that's what problem
Easy.
number 4 is over. So as long as you get it, you got it.
So,
No.
wait, so what is it again that we're doing?
Problem 4 is with the standard heat of formation, like how we practice in class. That was just like